All right, so let's get right into solving for the last two questions. So let's start with 2000 AMC 12, question 5. If absolute value of x minus 2 is equal to p, where x is less than 2, then find x minus p. So I did omit the answer choices here, and maybe they could be possibly useful because there's not really a clear format. So let me just write down the answers, or the choices at least, sorry. So it should be A is -2, B is 2, C is 2 minus 2p, D is 2p minus 2, and C and E is absolute value of 2p minus 2. Okay, so now let's kind of go about solving this question. Let's get back to our question. So what we're going to do first is take this condition and look at it. So we can draw a number line since we're starting off with x is less than 2. We mark 2 and we can just shade this portion in. And so if you were to take x minus 2, if you were to pick an x here, for example, like I pick 0. 0 minus 2 is -2. So it appears that since like obviously x is less than 2, x minus 2 should be less than 0. And that makes sense because x less than 2, you subtract 2 on both sides of the inequality, and you get x minus 2 is less than 0. And by absolute value, obviously, if something is negative, you're taking the absolute value of that. It's just the flip of it, the negative of it. So one thing we can do is, given this condition, we can write absolute value of x minus 2 is 2 minus x. And then you set that equal to p. So then now you solve for p in terms of x. You get x is solve for x in terms of p. You get that x is equal to 2 minus p, and then you figure out what they're asking for, which is x minus p. X minus p would just be 2 minus p, which should be equal to 2 minus 2p. So that would be for 2 minus 2p. So in essence, here you have to try to find out where you can simplify your inequalities, and that's going to play a big role in this next question as well. So let's get all the space we can for this question because it's a huge question. Okay, so let's move on to the next one, which is let f of x equal to absolute value of x minus p plus absolute value of x minus 15 plus absolute value of x minus p minus 15, where 0 is less than p is less than 15. They're asking for the minimum value taken by f of x for x in between p and 15. So for the very first thing, what we would like to know, definitely we have here that p is less than, by looking here, we have that p is less than 15. So one thing we could do is that we could write down this condition as is without worrying about whether it's going to be true or not. And we're picking an x value between p and 15. So what does this mean? So let's draw sort of the number line, and then we're going to say, okay, x is here, then p is somewhere here, and 15 is somewhere here. So now let's evaluate the absolute values and see if we could take out the absolute values and replace it with just normal expressions. And so if we have, since we have that x is between p and 15, we know that x minus p will either be 0 or it'll be positive. So as a result, we can just write this simply as absolute value of x minus p is x minus p, since we're basically guaranteed that it'll either be 0 or positive. Then we have x minus 15, and we know that x is less than 15. So if you subtract 15 from x, you're going to get a negative number or 0. And that would mean that our x minus 15 would be negative of x minus 15. So it would be 15 minus x. And now this is a little like more tricky one, at least at first, because this, if you do x minus p, that's positive, but x minus 15 is negative. But one thing you need to realize is p, the condition over here is p is p is greater than 0. So p is greater than 0. So as a result, it's important to realize that you're subtracting 15, and now you're subtracting another positive number on top of that. So that means it's just going to become more and more negative. And so because of that, we know that x minus p minus 15 is definitely less than 0. So then you're just going to take the negative of it. So it'd be 15 plus p minus x. Okay, so now we evaluated the absolute values and simplified them into without absolute values. So now you can just plug that into f of x. So f of x is equal to x minus p plus 15 minus x plus 15 plus p minus x. And so this cancels, and negative p and positive p cancel. So you get this 30 minus x. And they're asking for the minimum value taken by f of x for x between p and 15. And obviously, the way you would, since like it's negative x, you want to make x as large as possible to make f of x as small as possible. And the largest value we can pick for x is obviously 15 based on this condition. So let's take x equal to 15. And if we do that, then f of x is equal to 30 minus 15, which is equal to 15. So the minimum value taken by f of x is 15. Straightforward question. I think the main point here is this step over here, and again, similar to this step over here in this question. And basically drawing out a number line and recognizing which ones are greater than and which ones are less than each other. So you could simplify the absolute value to simple expressions without absolute values. And I think that's a key point to actually both of these questions. Okay, so now let's move on to the next portion, which is another example of absolute value. So it's like a little bit more involved per se. And so let's get to it immediately. So let's write out our expression again. So absolute value, so square root of 5 times absolute value of x plus 8 is equal to square root of x squared minus 16. What we're going to do is we're going to square both sides because we can never be wrong with that. So f5 times x, absolute value of x is equal to plus 8 is equal to x squared minus 16. So now we're going to use the property that absolute value of x squared is equal to x squared. And what we're going to do is we're going to make a substitution like we talked about with systems of equations. We're going to set y is equal to absolute value of x. And now we're going to plug it in. So now we get that this is 5y plus 8 is equal to y squared minus 16. Subtracting 5y on both sides and 8 on both sides, we get that y squared minus 5y minus 24 is equal to 0. And then we're going to use factoring here, which is actually to be covered in the quadratics and polynomial section. But for those of you that know it, just feel free to follow along. So we need to find something such that it adds up to negative 5, and multiplies to negative 24, and that would be negative 8 and 3. So it's y minus 8 and y plus 3 is equal to 0. And that means the solutions are y is equal to 8 or negative 3. And so now you substitute back in and you say, okay, absolute value of x is equal to 8 or absolute value of x is equal to negative 3. Obviously, we know that absolute value of anything can't be negative, so you cross out that. And you end up with two solutions, either x is equal to 8 or x is equal to negative 8. And obviously, as a best practice, just to make sure, we're going to plug this back into your original equation. So we're going to say 5 times absolute value of negative 8 plus 8 is equal to square root of 8 squared minus 16. So this is obviously square root of 48, and this is also square root of 48. And on a similar note, let's do 8 as well. So, oh, it should be negative. And this is 8 squared minus 16. And again, this is also square root of 48, and this is also square root of 48. So we got both our solutions, and obviously they're asking for the product, which is 8 times negative 8, and that would be equal to negative 64. Okay, so yeah, that's about absolute value, and there are definitely better, more interesting questions with absolute value, which we may look into later. But without further ado, let's move on to the next type of function, which is logarithmic functions. These are really important, especially when it comes to AMC 12, but it's definitely really, really useful in AMC 10 as well, especially when it comes to exponential questions, which are part of the AMC 10 curriculum, but they can often use log to simplify a lot of the problems. So let's go over the log definition and then obviously some of the basic identities or properties of log. So basically what it is if you have something like a to the c is equal to b, then what you do is you take the log base a, so whatever is here, the base, it's at the bottom, and then you put this here, and that's equal to c. And so that's how it works, like we have it right here. And we have some conditions, which is that b is greater than 0, and a is greater than 0, and a is not equal to 1. So these are some basic conditions. And by definition, we have that something to the power its own log, like base, like a to the power log base a of b is equal to b, and log base a of b is equal to log base. So if you have, like, for example, right, this can also be rewritten as log base 3 squared, 2 squared, and this actually would be equal to log base 3 of 2. So that's basically what it means. And this is a really powerful thing to realize, because it can be useful in many, many different scenarios. And you might not, like, you can easily quickly simplify a problem, because remember, in AMC, you need time. And instead of doing the whole change of base and basic definition, this idea can be really, really useful. So I would personally take a note of this. But yeah. Sums and differences. Log base a of b plus log base a of c is equal to log base a of b times c. Pretty straightforward. There's another one with subtraction. And then we also have that log base a of b to the power c is equal to c times log base a to the power b, a to the b, a of b, sorry. So all you do is you take the power outside, and that's the way it works. So if you had something like, a log base 9, or I should say log base of 4 of 9, maybe, yeah. This would be equal to, I should say log base 2 of 9. Then this would be equal to log base 2 of 3 squared. And all you do is you take this outside. So this is equal to log 2 times log base 2 of 3. So that's how it works. In other words, also, one thing to make sure that you know is like the change of base formula, which is right here. And all you can do is you can just take, on the top, you just take log base anything of the base of the, of the number, and then you take the log of, with the same log base of a. And so you get some things. And this can be really, this is like the very basic stepping stone that can get you a lot of things. For example, the fact that, so the fact that we saw over here that log base a, just a second, let me clear up some space. Okay. That we saw that log base a to the of b is equal to log base a to the c of b to c. The way this works is that, let's take this and we're going to do a change of base. So we're going to say this is equal to log base, I'm just going to call it log. And if you have normal log, that means log base 10. So it's log b to the c divided by log a to the c. And then we use this. So then we get that c log base b divided by c log base a. These two cancel. So it's log base b over log a. And then this is obviously log base a b. Flipping back. So then you just get the equality right there. So change of base is really, really important. And I think all of these are pretty important. So it's important to take note of it. And it's just about applying it when you need it. So yeah, something that's also important is to make a common base. So for example, if you had something like this, then you might want to rewrite it as this because you get a common base, and then you can just rewrite it this way with the sum for like formula kind of thing, or like identity of log. And so also here 64 is better common base than 2, because if you were to use 2 for some reason, this is how it would look. So it would be log base 2 of square root of x plus log base 2 of cube root of x. And then you just get, okay, this is log base 2 of x to the half plus x to the 1/3. So that's what, x to the 5/6. Yeah, it completely looks weird. Or no, sorry, this would be y. So then it would be x to the half and y to the 1/3. This doesn't really look really neat or clean, and neither does it seem really useful. So it's better to just use 64 to avoid fractional powers, although it's allowed. Okay, so let's go on to a quick example. And here's where I'm going to bring in something related to change of base and reciprocals. So what is the value of a for which this is true? And so now we're going to look at a small identity, which wasn't listed in the previous slide, to actually kind of get you familiarized in this question. So we can kind of like derive it in some sense. Okay, so the way it's going to work is I claim that log base a of b is equal to 1 over log base ba. Like I claim this is true. And the way it's going to work is you're going to do a sort of change of base idea. This can be rewritten as log b divided by log a. And obviously this one can be written as log a divided by log b. And if you take the reciprocal, 1 over something is the reciprocal of it. So it becomes log b divided by log a. And voila, this works. So this, again, is a really important thing to remember. Okay, so now we're just going to use that to our advantage here. So 1 over log base 2 of a should be log base a of 2. 1 over log base 3 of a should be log base a of 3. And 1 over log base 4 of a should be log base a of 4. That's equal to 1. Now we do the sum, since all of these have a base of a, so then you just get that this is log base a of 2 times 3 times 4 is equal to 1. So then you have log base a of 24 is equal to 1. And log base a of 24 equal to 1 basically means that a to the 1 is equal to 24. And the only way that's going to work is if a is equal to 24, right? And so that's our answer. It's pretty straightforward, but I think one thing we discovered in this one is that log base a of b is equal to 1 over log base b of a. That's something important to remember. But at the end of the day, everything is change of base. So just to reiterate what change of base is, it's log base a of b is equal to log base c of b divided by log base c of a. And so this is a very important thing to remember. For logs, if you know these properties, you're basically done with the question. And we'll take a look at a more recent AMC question, which actually just is as simple as following the rules. Okay, let's read the question. The value of x that satisfies log base 2 to the x of 3 to the power 20 is equal to log base 2 to the x plus 3 of 3 to the power 220 can be written as m over n, where m and n are relatively prime positive integers. Find m plus n. So in this question, we're just going to write down our expression and move on. We're just going to keep using the rules that we can to simplify these expressions, or both sides of the equation. So first things first, we're going to use the rule where you take out the power. So if there's a power inside a log, if you remember, so it's like this is equal to c times log base a of b. So we're going to use this rule. And what we're going to do is we're going to rewrite this as log base 2 to the x of 3. And we're going to take out the 20. And on this side, it's going to be 20 times log base 2 to the x plus 3 of 3. Okay. Now we're going to use change of base to our advantage. And the way we're going to do this is we're going to take the base as 2. Because we have on the bottom 2 to the x, and we have 2 to the x plus 3 as a base. And we want to get rid of the 2 to the power in the base. So the way we're going to do this is we're going to say this is equal to log base 2 of 3 divided by log base 2 of 2 to the x. And then this is equal to 2 to 2020 times log base 2 of 3 divided by log base 2 of 2 to the x plus 3. So far we're going good. It looks straightforward. One thing you realize is both sides have log base 2 of 3, so you can cancel that out. And yeah, and I think both of these sides have a factor of 20 as well, so you can make this 101. Yeah, so that's where we're at so far. So now what we're going to do is we're going to simplify this. So remember the rule that log base a of a to the b is equal to b. Okay? And so using this rule, what we're going to do is we're just going to simplify this as 1 over x is equal to 101 over x plus 3. Because log base 2 of 2 to the x should be x, and log base 2 of 2 to the x plus 3 should be x plus 3. Okay, now we're just going to cross multiply. So we have x plus 3 on this side and 101x, so it's cross multiply. And then you subtract x on both sides, so then you get 100x is equal to 3, and you divide by 100 on both sides, so you get x is equal to 3 over 100. And so basically m over n is equal to 3 over 100. It's in simplest form. And so m plus n is equal to 103. very straightforward question. As long as you follow the steps of log, you should be able to get the answer. And I think this is what is really nice about AMC as well. I guess it's in some sense a free question on the AMC 12, because as long as you follow the log steps and simplify very quickly, you should be able to solve the question. And so yeah, that's basically about it for absolute value and logarithms. And next we will move on to floor function and ceiling functions and more. So